Little different. We're cracking open a real deal GCSE maths paper, but forget your boring revision guides. Think of this as an exclusive insider's tour. We're literally going to walk through it together, page by page, so you can see exactly what's coming and, more importantly, how to beat it. Seriously, what if you could do a little reconnaissance mission before exam day? Well, that's exactly what we're doing. We're going to break down the structure, decode what the questions are really asking, and get you into the right mindset to absolutely nail it. This isn't just about remembering formulas. It's about strategy. And our tour starts right at the beginning. Yep, before you even glance at question 1. The first couple of pages might seem like just admin, but trust me, they are packed with crucial information that basically sets the rules of the game for the entire exam. Okay, look at this. The front page. Most people just scribble their name down and flip right past it. Big mistake. You need to stop, take a breath, and read this. This is your mission briefing. It tells you everything you can and can't do. Let's zoom in on the important bits. Right, here it is. The single most important sentence in the entire exam paper. Without sufficient working, correct answers may be awarded no marks. Let that sink in. You could have the right answer, but if you don't show how you got it, you could get 0 points. They want to see your brain on the page. It's how they give you credit, even if you make a tiny mistake at the end. And of course, you see that line, calculators may be used, so have that weapon ready. And check this out. The examiners even give you a little gift. It's a formula sheet. It's basically a built-in cheat sheet. Before you've even started, they're handing you the formulas for the area of a trapezium and the volume of a cylinder. They're not trying to trick you. They're literally giving you the tools you need. So make sure you know it's there. Okay, let's dive into the questions themselves. Now, these exam papers are actually designed pretty cleverly. They ease you in. The first few questions are like a warm-up lap in a race. They're there to help you build some confidence and get some easy marks on the board right away. So here's a classic opening question. They give you a box of numbers and ask you to pick out certain types. Find the odd number, find a multiple of 7, find a factor of 24. A factor, by the way, is just a number that divides into another one perfectly with no remainder. See? The whole question is just a quick test. Do you know your key terms? And honestly, the strategy for these is just don't panic. It all comes down to one thing. Do you know the definition? If you know what a prime number is, this question takes about 5 seconds. You just scan the list and grab it. It's a test of precision, not some super complex calculation. Another classic warm-up, negative numbers. They love to test these. Here, they've wrapped it up in a table of city temperatures to make it feel like a real-world problem. But at its heart, it's asking you things like, what's the difference between -8 and -14? It is so easy to make a silly mistake here. So my advice? Just slow down, picture a number line in your head, and double-check it. All right, warm-up's over. Now the paper starts to shift gears a little bit. We're moving into questions where you have to interpret visual information, charts, graphs, and diagrams. Think of these like puzzles with pictures. Pictograms. They look so friendly, don't they? They almost seem like the easiest question on the whole paper. But be warned, they almost always hide a nasty little trap. You see all those cute dog symbols and you think, okay, one symbol, one dog. But that's where they get you. So I'm asking you right now, what is the absolute number one first thing you look for? I'll give you a second. It is always, always, always the key. Look at the key for this question. Each one of those little symbols doesn't represent one dog. It represents 8 dogs. If you miss that one tiny detail, every single part of your answer will be wrong. Now let's switch from data to shapes. This problem is a perfect example of a geometry puzzle. At first glance, it looks a bit complicated, right? But it's really just about applying simple rules, one after the other. For instance, you know the angles in that 4-sided shape, the quadrilateral, have to add up to 360 degrees. Once you find that missing angle, maybe it's part of the triangle next to it. And oh, look, it's an isosceles triangle, which means 2 of its angles are equal. See? Each step you take unlocks the next clue. Okay, we are now entering the heart of the paper. This is the algebra section, and this is where being methodical and super careful really starts to pay off. For these questions, showing your work isn't just a good idea, it's everything. Now, this slide points out something that trips up so many students: the huge difference between simplifying and solving. When you simplify on the left, you're just tidying up.
You're a bartender at the end of the night, putting all the whiskeys together and all the yais together to make it look neater. But when you solve on the right, you're on a mission. You are trying to find the one single magic number for x that makes that whole equation balance perfectly. And look at this. This exact phrase is pulled straight from the exam paper. It's a direct command from the examiner. This isn't a suggestion. They are telling you what to do. They want to see every single step. Show me you expanding the brackets. Show me you moving the x terms to one side. Show me you moving the numbers to the other. Every line you write is another chance to score points.
And now for the last leg of our tour. We're at the bigger, high-mark questions. I like to think of these as the final boss battle of the exam. They take a bunch of different skills you've learned and mash them all together into one big challenge. This is such a classic problem. How many small boxes can you fit inside a big crate? Now, your first gut instinct might just be to divide the volume of the big crate by the volume of one small box. Stop. Don't do it. That's a trap. You have to think in 3D. You need a proper plan of attack. So the real key here is to forget about volume for a second and just think about physical space. Look at step 2. The crate's edge is 27 centimeters long. How many 5-centimeter boxes can you actually line up along it? Well, 5, right? Because 5 times 5 is 25, and you can't squeeze a sixth one in. You do that for the length, the width, and the height. Then you multiply those 3 numbers together to find out how many boxes actually fit. It's that logical process they're testing, not just your ability to press the divide button on a calculator. And you know what? That's really the main takeaway from this whole tour. An exam paper isn't a random collection of impossible tasks. It's a series of puzzles. From the instructions on the very first page to the way they word the very last question, it is filled with clues. Your job is to be a detective. Spot the clues and then pull out the right tool for the job. So, now that you've had a look inside the machine, what's your next move? Are you going to go back and master those warm-up definitions? Are you going to practice spotting the traps in data questions? Or are you ready to tackle those big multi-step problems? Whatever it is, you're now heading in with a plan. You're ready to crack the code.